Hi, my name is Kuba, and we're in an acoustics lab, more specifically, the audiometric booth. I've been working in this lab for about 3 years now on my master's, and I'm about to graduate. I want to crowdfund my project once I graduate because I think I've developed a pretty cool product. So, in order to do that, I need some coin, and this is why I'm applying for the Engadget Insert Coin competition. So in this short video, I'll show you the hardware first, because I know you're waiting for that. And then I'll show you how I'm using this hardware for my project. Maybe we'll run into some other students that are also using this hardware for their project. And then finally I'll show you the facilities at my disposal to make this all happen. First of all, this video is best experienced with headphones. So if you don't have your headphones on, just pause, grab your headphones, come back. Because that way I'll be able to talk into your right ear. And I'll be able to whisper into your left ear. Because what's going on here is that this is actually a B&K mannequin with a contour video camera strapped to his head, which is now going on my head. So that you can see from my perspective. And right now you're listening through the headphones that the mannequin is wearing. So these headphones are part of my project, and I'm going to put them on so that you can see and hear from my perspective. So give me a second to get the headphones on. The right piece, the left piece, alright. Alright. I'm good to go, and let's take a closer look at this hardware at the electronics bench. So, getting out of the audiometric booth. This is our main lab area. And come over to the prototyping bench. So what we've got here is the Auditory Research Platform, what we call the ARP for short. So that consists of the earpieces and the Beltpack. Let's start with the earpieces. So it's important for us to get an acoustic seal with the ear canal, and we want it to be comfortable. So we use the Sonomax SonoFit technology, but this could work with a traditional custom acrylic piece like that, or maybe generic comply tips like this. You can really use whatever you want. This is our preference. So we, just in case you're not familiar with the SonoFit technology, but Engadget reviewed them at CES 2 years ago. Basically, it's a balloon-like silicone, 2 layers, and it's inflated inside your ear with a 2-part silicone that cures and just takes the custom shape of your ear. So this is mine, and it'll stay like that. So we take this shell and fit it with basically components that are used in hearing aids. So this is a balanced armature driver. That's a dual driver, so that's a speaker with 2 drivers, and we can stick that down inside the earpiece. Alright, and then there's room for a microphone. So basically each earpiece has a little microphone here. That's the OEM outer ear microphone, and a microphone inside, so that's the inner ear microphone, and a dual driver, a speaker right there. So that's about it for the earpieces. So these plug right into the Beltpack, which has got all the DSP electronics inside of it, and a few LEDs and buttons. So basically what we've got going on here is the micro USB for charging. There's a USB port, 3.5mm audio jack for any communication device you can plug into here. Basically anything that you can rewire to have a 3.5, SD card, and Bluetooth. There's a lot packed into this little box, so we can control that. We've got that interface with Android, so this is just a little mock-up interface for me. It allows me to control certain parameters that I'll show you later on. But that lets us run algorithms in real time. So that's what's really exciting for us, is that we can use anything picked up by the microphone inside or outside the ear and the speaker, and we can process all that here and program it for all sorts of different research projects. And our hope is to really have this open programming, open auditory platform that we can develop on. So let's go over to the whiteboard and I'll show you. All right, so before we get into my project, I'm just going to tell you guys about a feature I think you're really going to like. It's called Talk Through the Ear. So if we draw the really quick model of the ear, then this is your ear, this is your eardrum, and we're going to put our headphone inside of it. Where's our microphone here, our speaker here, and this is your earpiece. So normally when you talk, your voice, this is some soft and tissue, this bone and tissue, your voice is coming through here. Normally when this plug is not in your ear, you hear yourself from inside and you hear yourself back through your ear here. That's why your voice sounds different when you record yourself versus when you're speaking live. And what happens when you plug your ear with your finger or with a plug and you talk, you don't get this outside path and you only hear your voice from the inside, and that's called the occlusion effect. So one of the features we have that takes advantage of this is there's a little microphone here, so we're picking up your voice inside the ear, and we can actually use that voice to transmit over a phone conversation. So if it's really loud here, like 90 decibels, and because you're in a bar or whatever, and let's say that just to keep the math simple, let's say you have a 30 decibels of attenuation in your plug here. So inside your ear canal, it's 60 decibels. So this, the signal to noise ratio is really nice because we're picking up your voice in a quiet environment. Basically, it's behind a hearing protector, behind an earplug, and we don't get any of the disturbance from the environment. So this is called Talk Through the Ear, and it's available right now. It works on the prototype. I just wanted to mention it because it's an awesome feature. I know you're gonna like it, but not sure if I'll have a chance to demo it later on. So just real quick about dosimetry. So basically my project is from hearing conservation. So that means I love music, I want to preserve my hearing and be able to use it as long as possible. So the two most important factors are how loud, so how loud is it, the SPL, for how long. How long am I listening? How long am I in this loud environment? So let's just say 80 dB is about the noise on the street. I'm walking down the street, there's some noise, someone slams the door, there's construction, impulse noises, then I go into a bar, this is 90 plus, I'm going into the bar, I'm in the bar for a while, then I go home and it's nice and quiet, but then I turn my personal music, my MP3 player on, I'm listening to music, then I turn it off, it's quiet again, I'm watching a movie, and then the story. So let's say this was 85, this was going up to 90, this was 92, this is 85, and let's say it's 85 again over here. So how do we know at the end of the day, am I safe or not? Did I go over my allowed exposure or not? Well, in occupational conservation programs, 85 dB for 8 hours is the limit. So 85, let's say this was 8 hours, that would be your 100% dose here. That's the max. So, well, look at all this, obviously we don't have the same noise level for the whole period of the day. So we got to average this all together. So that means we make an equivalent level, so an LEQ. So let's say the average would be here, and that's your LEQ level. And in this case, with this example, okay, we were safe in this case, but it's clearly really difficult to keep track of all this, especially when you got your personal music player involved, and we're trying to make that simple. So just like your GPS says 2 hours to your destination at this speed, when you're listening to your music, it's going to say at this level, you have, 2 hours of safe listening left. If you turn it up, your time's going down, but if you turn down your music, your time's going up. So let's say you're on a flight, you're on a long flight, you want to be listening for a while, you're going to be watching a movie, maybe you want to turn it down a little bit because the Android app is going to tell you, hey man, you're going to be at risk here, not in this case where, in this case you were safe, but So basically, we're trying to give you the information so you can make the informed decision and preserve your hearing.
Yeah, Kuba, so here basically what you see is that this research platform, this development platform that we do have here, looks large, but can actually be prototyped in a very small footprint, small form factor, and allows for the prototyping of a lot of algorithms that could be useful in research, and that could be later implemented in a real embedded in-ear device. So this is really what we use, and that will really enable a lot of new applications from product development, gaming industry, medical applications, and obviously fundamental research on the auditory system.